Welcome to the InnoEnergy Masters Plus webinar about our master program in nuclear energy, EMINE. My name is Machteld van Rijsingen. I am head of InnoEnergy Masters Plus, and I'm here today to welcome you to the webinar and talk you through what's going to happen. We have interesting presenters for you. We have Jordi and Dolores from the EMINE program and Josh from our admissions office. They're going to tell you more about the program and also on how to apply. After their presentation, there will be time for a Q&A. If you have any questions, please post them in the questions bar, and then we will answer them at the end of the presentation. So before, with no further ado, I want to give the floor to Jordi, who will introduce himself and the Master in Nuclear Energy.
Hello, everybody. Thank you to attend this webinar. I'm the program director of the Master in Nuclear Energy, EMINE, and I'm going to present a little bit what is the content and how the master works. So this is the contents of my presentation. First, I want to address this question: why nuclear? Why you should be interested in studying a master in nuclear energy? Then I will go through the program overview, and then we go through career opportunities after you graduate and the unique points of our program. Afterwards, Josh will present you about the admissions, what are the requirements that you need to present, and finally we have few time for questions and answers. If you have any question, we can try to answer. So why nuclear? Okay, I like to present always this plot. I call it the scary picture, because here we have the electricity production by source in the whole world in the last 40 years. And as you can see, in 40 years, we have more than doubled the production of electricity worldwide. And you would think that renewables are playing a big role on that, and we are transforming the energy market. But when you check this plot, what you see is that coal and gas are still the main sources of producing electricity worldwide. So more than 50% of the electricity is produced from fossil fuels. Then we have nuclear, we have hydropower, and then we have renewables, wind stronger than others, solar increasing, but there is a big gap in between. Okay, if we check primary energy, so here we are talking about electricity, if we check primary energy, it's even worse, because you can see here that fossil fuels are accounting for more than 80% of the energy, and then we have renewables and nuclear present here. But so in order to make this transition to transit from using fossil fuel to clean sources of energy, we have really a big problem in front of us. So it's going to be very difficult. So we are going to rely on we are going to need all the sources of energy that are possible, clean sources of energy, to make this transition. But it's clear that it's going to be very hard. And if you see the increase, it's always increasing, it's still increasing. In the economical crisis of 2008, people were saying, okay, we have reached a plateau and now energy consumption is not going to increase that much, but it was not the case. It kept increasing. In the early 2020 also, we thought that maybe we don't need so much energy, it's going to stall, but it's still increasing. And now we have seen the surge of data centers and artificial intelligence, which require a lot of electricity. So this means that this curve is going to still increase. So we need to get rid of gas and coal or reduce gas and coal reliance, but increase the electricity production. So it's really a lot what we need to produce. And but what are the safest and cleanest sources of energy that we need to implement in the future? I like this figure, which is from a very nice website, which is called Our World in Data. I recommend you to check it out because they have a lot of very nice plots which help us understand the world. And this is very nice. It just shows it has two dimensions. This plot on the left side we have the death rate from accidents and air pollution, and on the right side we have greenhouse gas emissions. And so these are per kilowatt hour produced. And you can see here clearly greenhouse gas emissions. They account for everything from the mine to extract the materials that you need to make a solar panel, or the energy you need to extract uranium in the mine, to the building of the nuclear power plant and the decommissioning of the nuclear power plant. Everything together divided by the energy produced by the nuclear power plant or by a solar panel. And you can see here greenhouse gas emissions. The lowest one in this case is nuclear energy. Wind and solar, all of them are very good and have very low emissions per kilowatt hour produced. On this hand, we have like death rate from accidents and air pollution. And again, this accounts for everything, all the accidents that happen in the mine, in the manufacturing of a solar panel, or in the working in a nuclear reactor. It counts for accidents in nuclear reactor like Chernobyl, like Fukushima is all accounted. And then it's divided by the amount of energy produced. And if you check that again, a nuclear is very similar to other renewable sources of energy. So it's not strange that nuclear is really considered one of the cleanest and safest sources of electricity. If we look at the impacts of the technology, we can see also this is the thousands of tons required of materials to generate 1 terawatt hour. And so you need to generate much more materials to generate electricity from solar, hydro, or wind than that you need for nuclear. So with all of this on the table, it's not strange that the European Parliament backed nuclear in the European taxonomy. The European taxonomy is a way to categorize the different technologies for producing electricity or energy in general, and they want to give like certify which technologies are good or bad in order to make this energy transition. And to make the energy transition, nuclear is seen to be very important for that purpose, okay, for what I just mentioned. And so no wonder many countries in Europe, in the US, in Asia are backing up nuclear programs. They want to increase the nuclear production. And what's more now with the artificial intelligence and data centers, many companies are trying to secure their own electricity. These things, the data centers, they require the same quantity of electricity 24 hours, 7 days a week. So all the time with the same production. So nuclear is really, really the best choice they have. So the prospects for nuclear are to double or triple the electricity production in the coming years. So that's what has been mentioned by the World Energy Outlook, and many countries are already pushing to get this done. It's going to be very difficult, and it's going to require a lot of manpower in the technological aspects. So you are here engineers that want to become nuclear engineers, and they are going to need you in order to make this transition, to make new reactors into reality and to make them deploy them quite fast. But not only that, it's going to require, if we want to deploy nuclear reactors in the market, it's going to require a lot of also economical aspects that need to be presented to companies, to regulators, to governments, and this is going to require also this aspect that the InnoEnergy masters is giving you, so the economic side of the problem. You will learn how nuclear works, but I just wanted to give some words to just to show the complexity of the nuclear reactor. And here you have a nuclear power plant, typical pressurized water reactor, and you can see many components. And if we just go and look at the, let's say, the primary and secondary side of the reactor, like where the fuel is in this green, this green vessel. And if we look from the top of the core, we see here is a map of temperatures going on in the reactor. And each of these boxes is something like I show here in the picture. So it's a bundle of small metallic tubes, and inside each tube we have the nuclear fuel. If we go into more detail, we can see that this is a zoom in the fuels. You have to consider that each of these pipes or rods, we call it fuel rods, it's about 1 centimeter in diameter, so they are very small, and the space in between is even less. It's just a few millimeters. Water is circulating through these, and it's just extracting the heat from the fuel rods, cooling down it, and then this water can then transfer to another system and generate electricity by going to the turbine. Okay, within the fuel rods is where the fissions are happening, and every time a fission happens, there are 2 or 3 neutrons that are appearing. And you know that when a neutron appears, these neutrons can cause further fissions, and this is going to provoke this chain reaction. What happens is that the neutrons that appear here are too fast, and they go through matter without doing any interaction. So this is not happening unless we have water inside, in between the rods. And so water here is going to slow down our neutrons, enabling a new fission reaction and enabling this sustained chain reaction. When every fission happens, one neutron will cause a new fission, and so on. And this is maintained for 2 years without changing the power in the reactor. So all of this is what you need to learn and understand, and you can understand that here there are nuclear physics involved, there are mass and heat transfer of water. It's very important. And we also have materials and other problems that need to be understood by the nuclear engineers. So about the program, the requirements are broad, but you need some background in order to initiate the master. So our preferred bachelors are mechanical engineering, probably the best, and then you have electrical engineering, chemical engineering, also physical engineering, and equivalent studies. It depends on the country, the names also change. And you have many masters in nuclear energy in Europe. What is new from what is different from EMINE is first that we have this unique focus on innovation and entrepreneurship that can be quite relevant in the nuclear sector in the coming years. So the nuclear sector has been kind of stable in Europe for the last 10, 20 years, but is about to change quite a lot with the implementation of new reactors, especially new small modular reactors. And this is going to require also this side of innovation and entrepreneurship. Another aspect of the master is that you will get a double degree in 2 different top universities in Europe. And finally, that we have a very strong involvement of the industry in many activities that we are doing in all the universities that participate in the program. Plus, aside from that, the InnoEnergy ecosystem also provides some support in academics. There are some courses that are also accessible for InnoEnergy students that they can be attended. We have a career center that allows you to help you grow in your career during the master and also afterwards. And then we have also the community plus, which is a very alive community of students, alumni and alumni that interact very well. And there is people making this work. So there are people assigned, and the job for them is to make these activities and make this community alive. Okay, the program contents obviously is the typical of nuclear engineering, energy. We have nuclear power plant management, operation, fusion technology, system components and materials, radiological protection and safety, also new generation reactor design, generation 4 reactors and small modular reactors, and so on. About the university selection and specialization. So these are all the universities that are involved in the program. We have UPC in Spain, in Barcelona. We have the KTH, Royal Institute of Technology in Stockholm, Sweden. And then we have a group of universities in France. We have INP Felma, which is in Grenoble, specialized on materials. And then we have several universities in Paris, École des Ponts, Université Paris, Paris-Saclay, and the Polytechnique de Paris. Aside from that, these are the nuclear universities, or the where experts in nuclear are present. We also have InnoEnergy, all the InnoEnergy masters have a course at ESADE, which is one of the top business schools in the world. And here you have you will have short course in innovation and entrepreneurship. In the end, you will have a degree from ESADE as well that will be very valuable in your curriculum. Why France, Spain, and Sweden? Well, I like to show this plot also from our vaulting data, where we can see the nuclear power generation in the different countries in Europe. And you can see that when you check this plot, you can see that Sweden, France is the highest in producing electricity from nuclear, but also Spain produces quite a lot. So Sweden 51 terawatts hour, Spain 58 terawatt hour. Okay, just Russia would be higher, and Ukraine is another country that was producing quite a lot. Now it's not so much because, you know, Zaporizhzhia power plant is not operable. We check the how is your path, your journey through the master. You would select as a first year either a KTH in Sweden or UPC at Spain, and so students will be in the two universities in parallel. And after the first year in the summer, everybody will come to Barcelona to have a course, a 2-week course in ESADE about innovation and entrepreneurship. And in the second year is done in France, and you can study material science for nuclear energy at Felma, or the commissioning and waste management in École des Ponts, fuel cycle engineering, nuclear plant design, nuclear reactor physics and engineering, and finally operations. These are the possible specializations that you can choose. So after the first year, you need to select. Well, actually the selection is done during the first year. Okay, here is more about what I was saying. Just the number of credits. You do 60 credits the first year, and in the second year is the first semester is about specialization, the courses, and the second semester of the second year is your master thesis that you will do it in a company. Okay, and there are many companies engaged in this with the master. Students usually take their internship in EDF or in CEA, Framatome. Different companies are hiring students, and in many cases, the student stays at the company after the internship. Okay, I just wanted to mention a few people, professors that are participating in the master, but I will go quickly. You can check that on the websites of each program. At Barcelona, I would like to highlight Francisco Calviño, PhD, who is a top expert in nuclear physics. He has worked a lot with CERN in Switzerland and done a lot of experiments and publications. In KTH, we have Per Olson, who develops a lot of research in small modular reactors. Also in KTH, we have Jane Valenius, who is the founder of Blaikala, is a startup that has designed a new reactor, an innovative reactor that works with lead. In Barcelona, we have collaborating with us Luis Enrique Ranz, one of the top experts in severe accidents analysis. And in France, we can highlight Yves Brechet, who is a commissioner of the atomic energy. So the career opportunities after your graduation, probably this is very interesting for you, what you can do afterwards. At this very moment, I can tell you that nuclear engineering is very good study that you can do now, because companies are hiring a lot. We have, for instance, in Spain, Westinghouse is creating a big hub of engineering, and they are hiring a lot of our students. Let me advance here. For instance, in Spain, there was a survey last year among the 23 companies and organizations in the nuclear industry in Spain, and they found out that in the next 5 years there will be a need of for a total of 1,433 highly qualified, so with a master's degree or equivalent, of new hiring. So this is a lot, because in Spain we have 3 master programs in nuclear energy, and each has about 25-30 students maximum per year. So there are not so many graduates every year, not comparable to this number of 1,433. That's a lot. And similar situations are found across Europe. And so this is very promising for you, and the market is growing at the moment. So, and also apart from that, another good thing about the EMINE program is that in the InnoEnergy Master Plus has a lot of alumni which are employed. You can check the companies here, and so there is a lot of nice stories. For instance, there was one of my students, this quite a long time ago, 7 years ago or 8 years ago, he then was founded a startup which is called Seaborg, and then they designed a new reactor there, and the company grew a lot, up to have about 100 employees. So that's stories that are happening in with our students. So finally, to conclude, I would like to highlight the unique points of the program. Basically, one very good thing is that you are going to have a double master degree in 2 top universities in Europe. So you are going to have 2 degrees and in your CV. So this is quite unique. You will not get that if you do an Erasmus program, for instance, because in the end, if you do Erasmus, okay, you have a stay in another university, but you have only one of the 2 degrees. And then it's really important that you have some interest in management, innovation, and venture creation. And this is a reason to take the master EMINE, because you are going to get a diploma from ESADE Business School. And I think that nowadays in nuclear, this can be really important. Of course, depends on what you want to do in the future, but a lot of jobs are going to also go into this direction in nuclear, where you need to have this type of knowledge. Then I would like to highlight that we have the label from the European Institute of Technology, that we are applying a unique learning by doing methodology. This is very important. So for instance, you are going to work with state-of-the-art simulation codes that are being used in the industry. And finally, that you have the opportunity to work with real life challenges from industries, but also startups. And also we have some challenges that are unique for InnoEnergy, like the Green Seed competition that allows you to interact with the other energy master students from InnoEnergy. Okay. And I think that's all from my side. Now I will be very happy to answer questions, but before that, let me introduce Josh, who is working at the admissions office, and he will give some words to you on how to apply.
Thank you very much, Jordi, for a brilliant introduction on why nuclear and why EMINE here with InnoEnergy Masters Plus. Hello everybody, my name is Josh Compton and I'm an admissions officer at InnoEnergy Masters Plus. We have just closed application round 1 for intake 2026, and application round 2 will be opening on the 10th of November. So if you haven't applied in application round 1, then don't worry. Next week you will be able to apply in application round 2. So I think I'll start by going through a little bit of information about documents required for your application. Again, if you've got any questions, you can just pop them in the chat box, and if they're not answered by anything that I'm going to cover, then we can take the answers to those questions in brief. When you're applying to study a master's degree with us at InnoEnergy Masters Plus, you must provide us with your bachelor's degree documents. And what we mean by that is your bachelor's degree certificate, your transcript of records, and then in order to be able to work out your cumulative grade point average, we need to see your final overall numerical grade and the grading system used by your university, which details the minimum passing grade and the maximum attainable grade. If your university has not issued these documents directly in English, you can ask them if they can do that. There are a lot of universities around the world these days where English is not a native language that still provide documents in English. But if your university does not provide that service, then you're going to have to get them translated by an official translator. You need to show us proof of English language proficiency, and that is because all of our programs are taught and assessed in English. We accept 3 different tests. So we have the IELTS academic test, where you need to have an overall band score of 6.5 and no section below 5.5, slightly higher no section below 6.0 if you'd like to study at TUE, but that's not in this program, so we don't need to worry about that. And then the TOEFL internet-based test, you need to have an overall score of 92 and a minimum score of 22 in the writing section. And then the Cambridge tests, we accept the Certificate of Advanced English and Certificate of Proficiency in English with grades A to C. If you take the Cambridge test, then please make sure that you share your results with KTH Royal Institute of Technology so that we can verify your results. You also need to apply with your CV and your passport. CV should be a maximum of 2 sides of A4. That would be ideal, short and punchy. And then if you have studied your bachelor's degree in any of the countries that you can see on the screen, so Bangladesh, Cameroon, Canada, Eritrea, Ethiopia, Nigeria, Sri Lanka, or the USA, then we need to have your transcript sent directly from your university to us. And if that's from Bangladesh or Sri Lanka, then this must be by post. And then if it's for any of the other countries, it could be by post or email. If you studied in Pakistan, then please make sure that your degree certificate and your transcript are HEC attested. So that's the Higher Education Commission. And if you've not yet finished your degree, the documents that you provide us with must still also be Higher Education Commission attested. This is a service that they provide for undergrads. And then for the European Masters in Nuclear Energy, please also provide a letter of motivation detailing why you want to apply for the program, what you'll bring to the program, and why you think that we should admit you. Thank you very much. Next slide. Thank you very much. Then we have the English test waivers. So as proof of English language proficiency, everybody needs to provide proof. And if you have studied in certain different countries, then you don't have to take a test. So I'm just going to go through the 4 different test waivers that are available in this program, and I'm going to go through what restrictions exist as well for these different waivers. If you have studied your bachelor's or master's degree in either Australia, Canada, New Zealand, the US, or the UK, then you can qualify for a universal English test waiver. And this means that you have access to all of the universities in the program. And in the European Masters in Nuclear Energy, this is also the case for the European English option. So if you have studied in English in the European Union, the European Economic Area, or Switzerland, you can also qualify for an English test waiver for this program. There are 28 countries located within the Americas and Africa that are presented in more detail on the admissions requirements page of our website. So when you go to InnoEnergy Masters Plus, then you can go to the application process tab and then down to the application requirements sub-page, and then you can scroll all the way down to the English requirements. You can have a look at these waivers and the countries included and the conditionalities that they involve at your leisure. But if you have studied in any one of the 28 countries in the Americas or Africa that are presented in detail on the admissions requirements page in English, and it's been a whole bachelor's that you've studied there, then you can also qualify for an English test waiver at all of the universities that are involved in this program. Finally, moving on to the special track waiver on the far right-hand side of your screen. If you have studied a bachelor's degree from one of the 16 countries in Africa and Asia Pacific, presented also in detail on the admissions requirements page of our website, then you can study at UPC and in France with this program. The special track waiver is not available for studies at KTH. So that means that you would have your first year at UPC in Barcelona, and then your second year you would move on to study somewhere in France. If you have studied in one of these special track waiver countries and you wish to study at KTH, please make sure that you take a test. Again, I just want to reiterate that all of this information is, at least we think, quite clearly displayed on our website. And if you've got any questions, then please do just let us know. You can fill in the online form for some further information, or you can email us at admissionsoffice@innoenergy.com. So I think that's it from admissions in this short overview, and I think we can start moving on to some questions.
Thank you, Josh. Very
Hello
clear.
again. Thank you, Josh and Jordi, for your presentation. I learned a lot actually, so I enjoyed it. I already have some questions from the audience for you, which I think could be relevant for anyone to learn more about. The first question is, what hands-on access is provided, such as access to reactor facilities, simulators, digital twin labs during the program?
Yeah, that's a very good question. So I cannot give all the details because I don't fully know in every university how it is. But for instance, in Barcelona, you have access for one side of full scope simulator. We go to the full scope simulator of the power plants located at south of Catalonia in Ascó and Vandellós, and we have 5 full days there training with the operator trainings, and you can train yourself on accidents. We follow emergency operational procedures and so on. And also we have we work with state-of-the-art simulation tools for safety analysis, for instance. And this is in my course. We teach RELAB 5 thermohydraulics, and in other courses, core design, we have others. Then depends on KTH. I think there are some trips to Westinghouse facilities there. In France, you are going to visit CEA facilities where they have experiments, and as well as EDF. In Spain as well, we go, for instance, to a power plant, to the I think that we go to Garoña, which is now being decommissioned, and we also go to a manufacturing factory in Salamanca where they make fuel. These are the type of trips that are present. So we do have a lot of this.
Thank you. And maybe linked to that, how much, for example, are simulation tools licensed or given to students? Can they do this kind of work themselves as well?
Sorry, can you repeat?
Are simulation tools licensed or given to students? So can they do their own simulator work?
That depends case by case. It depends on the simulation tool. So sometimes we decide to use open source or more open softwares. Then we can give the license directly to the student. For instance, there is a nice simulation tool or kind of replica, let's say, twin, we call it a twin of an integrated PWR, which is provided by IAEA, and we teach that how to use it and so on. This they can use afterwards. But if we are doing more like commercial stuff, then sometimes they can only use it in the lab.
Thank you. And next question, I have a master's in computer science background. Would I be eligible to apply for this course? So what kind of, because I see that the computer science, traditionally, I don't think it's a bachelor that you're looking for. So what kind of courses inside a bachelor are you interested in? So because I know it's not the name of the degree that you look at, but more the content.
Yeah, so if you have a computer science, you are going to be good in the program, in the sense that because we do quite a lot of programming in the program, there is a lot of programming knowledge that you require in nuclear engineering. On the other hand, you are going to miss some physics, like nuclear physics, and probably also fluid mechanics. These are going to be a couple of things that you are going to miss, but in principle, I think that you would be eligible for the master program.
And I mean, this is my question, but linked to it, if someone has taken, for example, courses in Coursera or edX to compensate for missing courses, would you look at those? Like if they've taken fluid mechanics on edX, can it be something that together with the degree in computer science would help to be accepted?
Usually we look at the official courses more, but obviously it can be an asset, or it can help. But usually what we look is what is the background directly from university degree.
All right, thank you. And then the same student, I already answered this question. He's running a startup in the digital twin and simulation space. Can the program be pursued while working remotely on his company?
Usually we recommend that you are not working while you are doing the master program, because this master requires a lot of dedication. There are a lot of activities, a lot of projects in all the courses, but it's obviously it's not forbidden, and you need to evaluate yourself. I think at this age, probably you have to know what you can handle, or you can see it with the time. I assume this would be a work that it's not like that you require 8 hours a day to work. So it depends on how much requirements it takes. But the master is it's a really intensive master, so it requires quite a lot of dedication.
And then linked to that, are there opportunities to propose or undertake project work aligned with my company's focus on, for example, digital twin, simulation, robotics for power plant and nuclear applications?
So these are very advanced topics. So the question is if the what you will learn is going to help in that direction. Is that the question?
I think what he's trying to ask is, for example, if you need to do a project work in a course, can he use the work that he's doing in his company as a project?
It really depends on each professor. So it really depends on the project, if it is going to be in the same direction, and if on the professor of each course. So this is really,
yeah.
But this type of activities and the fact that you are doing this kind of things is very good, and shows that doing this master is going to be really helpful for your career. And if you are trying to do things like that, like a digital twin, you will really need to learn about, for instance, safety analysis, because digital twin, it's can be applied for normal operation, but what I have seen is more applied to accidental situations. This is when you want the digital twin to tell you what's going on and what will happen if I do this or I do the other thing. So you really need to learn the sequences, accidental sequences that the reactor can have. And I don't think you can learn that anywhere but in a master or in a company working on that. My experience is ChatGPT is not going to answer right about that. So you will really need this type of learning.
Another question, could careers at IAEA also be an option after the program?
Yes, why not? This is a really nice institution, and they really need this side of entrepreneurship, innovation, more like this social side is also important in this type of institutions. I remember that we had a student that went after the master. He started working at IAEA, and he's still there. He worked for many years in IAEA already, so it's clear opportunity.
In fact, I would even say that we have graduates in many different organizations and companies, also some who have their own startups in Europe and worldwide. And as InnoEnergy, we can also put you in touch with those alumni, because they're often very happy to, for example, help you get started with an internship in their organization. So if you have a certain organization that you're interested in to work for, let us know, and we can see who we can connect you with that we already know who's done this master's. Next question, do you consider applicants who already have a master's program if the bachelor is not related to engineering? So if I understand the question, if the bachelor is not related to engineering, but the master is, can they apply?
Yes, I think so. Of course, if the master is related to, so if you have a master in, I don't know, mechanical engineering or aeronautics or things like that, maybe then you have taken courses. So we really look at the courses that you have done in the past to see if you are eligible. But we take into account the master, not only the baccalaureate, but the master is also, if you have done a master, is for sure considered.
And if you are applying after having done a bachelor's degree as well as a master's degree, then it's important that you include not only your master's degree certificate, but also your master's degree transcript. And this information wasn't mentioned in the admissions requirements section because it is the bachelor that is the necessary component for application. But if anybody has studied a master's or higher degree that in any way would support your application, then please make sure that you include information from those further qualifications in your application.
Thank you, Josh. I believe that was the last question in the webinar. I would really like to thank everybody for their participation, and I'm glad we had so many interesting questions to answer. If any of you is interested in our master program in smart electrical networks and systems, we have a webinar about that program tomorrow. You can find more information about that on our website. If you have any more questions on the nuclear energy program, the contact information for Jordi and Dolores is here on the slide. You can reach our admissions office @innoenergy.com. And we also have a lot of information on our website about the application, the requirements, the English, scholarships, fees, etc. So if you would have any further questions, please reach out to us, check our website, and we hope to see you next year in the program. Thank you very much.
Thank you, Martel, to organize this.